This video, we're going to talk specifically about the nomenclature of aldehydes and ketones. Now, if you've watched the video on multiple functional groups, I'm not sure there's a lot of new information in this video. I do have a couple specific notes about the nomenclature of aldehydes and ketones, but this is the functional group priority list for the whole semester. A lot of these compounds we haven't learned yet, so I crossed them out. Right? It's just the ones that are shown that we have to worry about on quizzes, at least right now. And so aldehydes get the base name Al, ketones get the base name ONE. Since they're both carbonyl groups, they both, when they're substituents, get named with the oxo prefix. So a couple specific notes on aldehydes. I already mentioned when aldehyde is highest priority, the suffix goes from E to Al. When we name it as a substituent, it's an oxo group. Now, because by definition aldehydes are on the end of the chain, as long as they're the highest priority, we generally leave off the locant because it's understood to be 1. So rather than being 3-methyl-1-butanal, we would probably just name this 3-methyl-butanal. I'm not going to make you responsible for a lot of common names for aldehydes, but 2 I think you should be familiar with. Benzaldehyde we've already encountered. And so you still need to know that. And then the simplest aldehyde is formaldehyde. And this is used a lot as a reagent. And so I think it's important to know what formaldehyde is. Not much more than that for ketones. If the ketone is highest priority, the E suffix becomes ONE. Just like an aldehyde, when a ketone is a substituent, it's not treated any differently. They're both named as an oxo group. And then I think you should be familiar with the common name for propanone, or the common name is acetone. We use this all the time in organic lab. I'm sure you've used it tons of times already, so you should be familiar with the formula of acetone, and that as the common name. All right, so I want to finish off with just a couple examples. In this case, we need to determine what group has the highest priority. So the fluors are out. They don't get any special priority. I then have a ketone and an aldehyde. Aldehydes are higher on the priority list. So the aldehyde is going to get the priority in this case. And then so it should get the lowest number as well. So I should start numbering from this end. Let me fix that pen. All right, now my substituents, the ketone, because it's a substituent, is going to be an oxo. So I have a 4-oxo, and then I have a 5,5-difluoro. So my name is going to be (5,5-difluoro). F comes before the O in oxo. And then, as I mentioned, generally we don't have to give the number for the aldehyde if it has the highest priority because it's understood to be number 1. So then this is going to be hexanal. And I don't have any chiral carbons. I don't have any unsaturation, so I don't have to worry about giving any stereo descriptors. All right, so in this case, we just have the one functional group, and we have a ketone. Now, when we're determining the parent chain, I gave this example specifically to talk about the fact that the longest chain has to include our functional group. So even though I could get 1, 2, 3, 4, 5, 6, 7, 8, 9, that won't include the highest priority functional group. So I have to go 1, 2, 3, 4, 5, 6, 7. Of course, when I'm numbering it, I want the functional group to be the lowest number possible. So I'm going to go so then my name, I have 3-butyl. And the position of the ketone is not understood, so I have to give the locant for that. So it's 2-heptanone. All right, here we have a cyclic compound. We have an isopropyl that doesn't get any priority. The alcohol would be higher than the isopropyl, but the ketone beats the alcohol. So my highest priority is again going to be this ketone. When I'm numbering it, of course this is going to be number 1, but then I want the numbering to be as low as possible, so I want to go in this direction so that my first substituent would be at 3 rather than at 1, 2, 3, 4. So my numbering should be as such. Then my substituents are, I have a 3 hydroxy, I have a 4 isopropyl, and then of course it's going to be cyclohexanone on the end. So I have alphabetically H comes before the I, so I have 3 hydroxy, 4 isopropyl. And then normally we have to give the position of ketones if we have a straight chain alkane, but in this case, again, because the ketone has the highest priority and it's cyclic, it's understood that that's going to be number 1. So if the number is understood, I can leave it off. So then it's going to be cyclohexanone. And then to finish us off, we do have chiral carbons, and they did show us the stereochemistry, so I have to give the stereo descriptors. So for carbon 3, that carbon would have the highest, or that group would have the highest priority. Then comparing these two, this carbon is bonded to 2 other carbons. This carbon is just bonded to 1, so I'll have 2 and 3. The hydrogen is already in the back, so I don't need to worry about switching anything. So I have 1, 2, 3, or counterclockwise. So this is going to be 3s. Assigning the configuration of carbon 4. Let's see. So here, this carbon is attached to 2 other carbons, whereas this one is attached to an oxygen. So that should be priority 1. That should be priority 2. That should be priority 3. And then, of course, the hydrogen is on the wedge. The hydrogen needs to, or the lowest priority group needs to be in the back in order to do the, to assign the configuration. So it's going to be the opposite of what it looks like when I have that hydrogen. So it looks like 1, 2, 3 counterclockwise, but I have to swap the configuration. So it looks like it's S, but it is in fact 4R. So then to finish off my name, 3S, 4R. I'm sorry, and I made a mistake here. I wrote hydroxyl. It should be, it's not letting me erase it, but this should just be 3 hydroxy, 4 isopropyl cyclohexanone.